But one of the big questions is, of course, why are we actually doing this here, high up in the north, in the subarctic? Well, there's two main reasons for it. One is that climate change itself is going to have a bigger impact here than further down south. And the warming itself is going to be higher at these latitudes than it is going to be further down south. And one of the things that's happening more frequently is that there's more and more nitrogen coming into the north, basically from industry and agriculture from the south, so from the middle of Europe.
The winter climate is changing. There is an increasing frequency of comparatively short-lasting warm spells causing partial or full snowmelt over large areas. Such warm spells are extreme in their nature, as they enforce major temperature changes on ecosystems due to the loss of insulating snow in winter.
Well, if these events are going to happen more frequently, what's going to happen is that you will get snow melt, like we're simulating here, which is going to expose all these plants. And in a basic principle, just warming the plants is not a big thing. But the moment this warm air moves away, then the plants are going to freeze because they're not going to be insulated by this thick layer of snow that we have here at the moment. And that's one of the big threats for these ecosystems down here.
Here at Håkøya, a small island near Tromsø in subarctic Norway, the researchers are studying how the plants will respond to winter climate change.
Here we are in the middle of a winter warming simulation. These infrared heaters we have here, they have warmed up these plots since Sunday, 5 days ago. The snow depth was around 50 centimeters, but now all the snow is gone. The plants here, they are now preparing for spring as they hold a temperature around 5 degrees. This is a situation which is quite common in these areas because a natural warming event can come here and thaw away all the snow. So this is a realistic simulation of what can happen in winter. And we will now, in a few days' time, turn off these lamps, and we will then see how the plants cope with return to winter temperatures.
The genetic makeup of the different plant species determines how they cope with the cold and with changing climate. Parallel with the field trials, some of the plants will be exposed to periods of cold and warm in a phytotron.
And in this part of the project we want to get more information on molecular mechanisms related with the cold acclimation of plants and the differences between different species that are involved in the project.
From other plants, they have identified many changes that are related to the development of cold tolerance. The researchers will concentrate on the so-called CBF genes that are known to respond to cold temperature.
Now we will look at the expression of these CBF genes at the beginning of the experiment and then during the warm period, and then when the plants are induced in cold temperatures again. So it will be interesting to see the differences in gene expression at different stages of the experiment and also between the different species.
Another part of the WINNIT project is to study how nitrogen will affect the plants during the summer months. This nitrogen originates from industry and agriculture in Central Europe and deposited in the north.
And because these plants are so nutrient limited, they need the nitrogen to grow. So we would expect if you give them a bit of extra nitrogen, they will grow faster and better. But then if you combine that with the winter climate change we're expecting, and that we're simulating here with these lamps, is that there could be a very strange interaction going on. Like for the summer they will grow more because of the additional nitrogen, but the potential damage from these winter warming events can have a really much bigger impact than those changes in the summer. but we're not entirely sure how these things are going to interact.